All right, good morning, class. It's a pleasure to be with you today. My name is Mr. Chris Miko, and I'm going to be your video instructor today. So everybody say it with me. Mr. Chris Miko. Good. Well, today we are going to be talking about science. And the topic we're going to be focusing in is air, water, and weather. And under that area of science, we're going to be focusing on specifically today the air around us, the atmosphere that forms this ocean of air around us. What are we going to be looking at today? Well, we're going to be talking about how air is matter. It's considered to be matter. And that air has a physical presence. And because of that physical presence, it forms a layer of air around the earth from which we live at the bottom of. So vocabulary terms for today, we only have a couple, and they're pretty easy. First, we have matter. Everyone say matter. Good. Matter is basically anything in the world, in the universe, that occupies space and has mass. So, we know that your tables are matter, that you're made out of matter. Everything around us that you can touch that takes up space is considered matter. And our other vocabulary term is atmosphere. Everyone say atmosphere. Good. An atmosphere, like I said, is the air that surrounds the earth. So let's think now, class. And I want you to take out your notebooks and I want you to write down what you think the answer is. Talk to some of your classmates and think about, can you fly a kite in outer space? And why or why not? I want you to think about that. I want you to write that down in your notebooks. Okay, so we're taking up space. And I'm giving you some time to write that down. So before we get to answer that question, first we need to take a look at how a kite flies and what a kite needs to fly. So we're going to start with looking at matter itself. And matter, as you know, has three states that it can be in. It can either be a solid, a liquid, or a gas. And that depends on what the temperature and pressure is that's going to allow something to be in a solid, liquid, or gas form. Now remember, all matter can be in any three of these forms. In fact, your desks can be a gas if you heat them up enough. In fact, you can become a gas if you get heated up enough. So any type of matter can be a solid, a liquid, or a gas. We're going to focus now on that third stage, the gas or the air stage. And here we have just a nice day at the park. We've got our kites flying, and we've got air all around us. Now, you ask, how do we know that there's air all around us? Well, you take your hand, and you wave your hand back and forth. What do you feel? Everybody do it. Get your hand up in the air. Yeah, there you go. Wave it back and forth. What do you feel? Do you feel something? Yeah, you do. That's air. All right? We don't have nothing around us. We are surrounded by air. And as we can see on this picture here, this kind of demonstrates the atmosphere or the ocean of air that surrounds the earth that we live in. And you can see how thick it is. Well, it's really not too thick, but it's still a substantial area of air that surrounds us and we live at the bottom of. We can liken that very similar to the ocean. Here we are in this ocean of air that we call the atmosphere, and it's very similar to animals living in the ocean. And in fact, from outer space, we can see that atmosphere around the earth. You see the clouds in the atmosphere, and it's a beautiful picture of the earth from space. So we actually have, we can see the atmosphere, and we have a great video here that from a NASA space shuttle, and you can actually see the outer edge of the atmosphere right here. Over here is the Earth, And then this outer band right here is the edge of the atmosphere before you get to the edge of the empty vacuum of space, where there is no air. And this is another video from NASA as well, where taken from Skylab, which was a temporary space station that we had to do science experiments. And from Skylab, they took this picture back in the 80s, and you can actually see stars shining through the layer of the atmosphere at the very edge there between the Earth and the outer edge of the atmosphere. So that leads us to our question. Does air take up space? What do you think? A, no way. We can move around in air, so it doesn't take up space. B, yes, air is matter, so it must take up space. C, it depends on how cold the air is. Or D, it depends on how high the air is. I'm going to give you 45 seconds to discuss this with your classmates, and I would like you to buzz in when you think you know the answer. You have 45 seconds. All right, I see that we have a student in classroom TCP5B that has buzzed in. Can I please have a student step to the microphone and tell us what you think the answer is?
So it must take up space.
All right, I heard that the answer is B. Yes, air is matter, so it must take up space. And you are absolutely correct. It does take up space. We felt it with our hands. It's there. So if it is matter, then we know that it must be taking up space. And this brings us to our experiment class. And in this experiment, video. We have a plastic container here. And there is a ball that's floating on the surface of the container. And what the scientist is going to do here is he's going to take this glass and he's going to put it on top of the ball, face down as he's holding it, and he's going to push that glass down over the water. Now the question is, what's going to happen to the ball? Is that ball going to stay here as he pushes the glass down on top of it? Is it going to sink partially? Is it going to sink all the way? Now, I want you to think about that, and I'm going to give you 30 seconds to come up with your hypothesis of what you think is going to happen. We need to add a slide for that. I forgot to mention that. Have them question slide of their hypothesis before they do the experiment. Are they confused?